It is still Sunday. We're continuing on our sixth grade post-course test and reflection, review would probably be the best word for it. And we're on page 4 of 6. And we are starting off with problem number 56 that asks, how many hours do sixth graders spend studying each night? Is that a statistical question? Yes. I'm assuming that the reason it is considered statistical is because we can do mean, median, and mode. Let's take a peek. Again, always using what determines whether a question is statistical. Let's see what good old Google. A statistical question is distinguished by two key characteristics. It anticipates variability in the data and requires data collection to answer. So, answers will vary, meaning there will be more than one possible answer. This variability arises because the question deals with characteristics of a group or population where individuals within that group may differ. How many hours do students in my school spend on homework each week? Requires data collection. To answer statistical questions, you need to collect data from a group or a population. This data can be numerical, heights, weights, categorical, favorite colors, types of pets. To answer the homework question above, you'd need to gather data from multiple students on their homework hours. In contrast, non-statistical questions, good, I like that, have a single definitive answer. The sun is yellow. Is the sun yellow? Or what color is the sun? That's only one answer. It's yellow. Does not require data collection to be answered. How many days are in March? This is not a statistical because the answer is always 31. Yes, good. In summary, a statistical question is one that explores the variability within a group or population, requires data to understand the variability. Okay, so how many hours do sixth graders spend studying each night? That will definitely vary depending on the students, and it will consist of a group. So we are going to say a big, fat yes. Should we? Yeah, let's do this. Did I? Okay, good. So let's do this. Let's take this information and let's plug that in there. That's always good since we found it. Let's include it in our notes because it's pretty good. I thought that was pretty good definition. Good work. Excellent. 56. 57. The commuting distances in miles for several students are 1, 1, 1, 4, 1, 7, 3, 2, 3, 7, 3, 7, 5, 4, 2, 5, 1, and 1. Display the data in a data plot. So a data plot is going to be on a number line. So let's do this. Let's create ourselves a little number line. Let's make it a little bit thicker. And let's do this. Boop. Nice. Yes. And now let's start taking. So we have 1, 2, 3. See, not having the data in numerical order definitely is not great. So let's do this. Well, we know that 1 is a data piece. 2, good. So 1, 2 is 3, yes. 3, 4, yes. 4, 5, yep. 6, is there a 6? No 6. But we can make a tick mark. 7, 6, 7. And that's as high as we go. Okay, so we're going to do this. We're going to put, oh yeah, look at this little technology we're going to do. We're going to make little boops. What color? Let's do blue. Let's do blue. And we have 1. Good. All right, now, so that it, oh, do we number the left side? No, we don't even number the left side. So let's do this. Infinite cloner. Okay, so 1. How many ones do we got? 1, 2, 3, 4, 5. 5 ones. 3, 4, 5. Let's make sure. Oh, see if I didn't double check. 1, 2, 3, 4, 5, 6. 1, 2, 3. So thank goodness I checked my work. All right, how many 2s do we have? 1, 2 2s. So 1, 2. How many 3s? 1, 2, 3. 3 3s. 1, 2, and 3. How many 4s? 2 4s. 1, 2. 5s. 2 5s also. Boom. No 6s. 3 7s. 1, 2, and 3. All right. And let's label that bottom on the line. Let's do this. Let's make that a little bit smaller. And let's do distance. This axis is distance in miles. Perfect. Boom. That would be a dot plot because it consists of dots. All right. I like it. Looks pretty good. Next question. A group of 5 sixth graders measure and record their heights. The heights in inches are 53, 54, 63, 55, and 55. Find the mean, median, and the median of the heights. Okay, so mean, we're just going to add them all up. Mean equals the sum of the numbers divided by the number of numbers. So let's add them up. 53, 54, 63, 55, and 55. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay, and that's a 54, not a, whoa. Okay, so adding up, that's 10, that's 20, and that's 5, 10, 28. 280, so 280 divided by 5 equals, and just 5 divided by 280, 5 goes into 28 5 times with 3 left over. 5 goes into 36 times, so 56. The mean is 56 inches. Where do we want to put that? The mean, 56 inches. That's the first question. And then the median, which is the middle. First thing when we do median, place in numerical order. And then find the middle. Find the middle number, or no, the middle, because sometimes you'll have 2 middles. All right, so hold on, there's my list of numbers. You got 53. You have 54. you have two 55s, and then you have a 63. So that is 1, 2, 3, 4, 5 numbers, 1, 2, 3, 4, 5 numbers, the middle. So we go boom, 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 and this would be our middle. So the median number or middle number is going to be 55 inches. Mean is 56. Median is 55. Good. All right. Find the interquartile range of the data. All right, so this is a little bit like box and whisker. So again, you first have to put them in numerical order. So having them like this is good because I'm going to take the lowest number, 53, and I'm going to mark that I wrote it down. Then I have 54, mark that I wrote it down because I'm doing numerical order. Then that's going to be 60. Then another 60. 62, 65, 67 twice, and then 70. So I'm going to count 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. And I'm going to find the middle. So boom, 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 boom. This is my middle. So that would be the inside. So now we're going to break them into, so we break them into two halves, this and this, and we're going to, so this would be the median, or I think this is Q2. It's considered Q2, and we want to find the middle of the other two halves. So we have what do we got here? Find the interquartile range of the data. Okay, the interquartile range of the data. So I think, yeah. So we're going to find them. I think this is right. This would be Q1, and this would be, all right, this is Q3, but that would give me an interquartile range of 7, and it's 10. So I did not do that correctly. Do I not include 62? Let's try it without including 62. Let's do this. So that's the median. That I know is correct. So let's take, actually, I think maybe we go from these two numbers. And I could look it up, but so that's going to be the interquartile. This is going to be Q1, which gives me 56, right? Between those, no, 57. Hello, Miss Rack. How did I get 57? I got 57 by, between these two, this is the middle. So 54 plus 60 gives me 114 divided by 2 is 57. And let's find between these two, this is going to be Q3. That's not a Q. It's going to be Q3. Yeah, I did it right this time. Q3. So you don't include the median when you're finding the middle. So you're finding the middle between these four numbers and these four numbers. So, and Q3 is going to be 67. So the range is going to be 67 minus 57, which equals 10. All right, that's better. I had to remember one little thing. Sorry about that. Good. So Number 60, identify the outlier in the data set. All right, so outlier, you can see it right away. We already know what it is. It's 144. So 144 is the outlier because all of these numbers are between 90 and 99. And then you have this outlier of 144. So that's the outlier. And that's that piece of data that does not fit the groupings. Good. So that's well beyond your set of numbers. 61, the data set 2, 3, 3, 4, 5, 6, 7, 8, 9, 9 shows the number of hours students study the week before a test. Find and interpret the mean absolute deviation of the data set. I did this one other time and I forget. I have a video of me doing it and I don't remember, but it was totally crazy. So let's look it up again. Let's see if I can. The mean absolute deviation. Yeah, see? All right, so that is not, yes, the MAD, totally. How do I find the mean absolute deviation? Please don't have that. Calculate the mean absolute. You first find the mean of your data set, and then each data point calculate the absolute difference between that point and the mean. Finally, average these absolute differences. Okay, so we're going to find the mean of this data set. So the mean is going to equal 2 plus 3 plus 3 plus 4 plus 5 plus 6 plus 7 plus 8 plus 9 plus 9 divided by 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We like that. So what do we got there? We got 5, we got 8, 12, 17, 23, 30, 38, 47, 56. Divided by 10 gives us 5.6. And now we take the distance between, the absolute distance between each of those numbers. So we're going to do 5.6 minus 2 and the absolute value of it. We're going to do 5.6 minus 3, 5.6 minus 3, 5.6 minus 4, 5.6 minus 5. Whoa, not a parentheses. That's an absolute value bar. 5.6 minus 6, 5.6 minus 7, 5.6 minus 8, 5.6 minus 9, and 5.6 minus 9 again. So what do we got here? We got 3.6. We got 2.6. We have 2.6. We have 1.6. We have 0.6. We have negative, but we're taking the absolute value, 0.4. We have 1.4. We have 2.4. And we have 3.4 and 3.4. Now we're going to add all those up. 12, well, that's 24. No, that's 30. So that's 30. And 1, 2, 3, 4, 5. That's 20. So 50, 0, 5. I think that's correct. That's 10. That's 12, 13, 14, 15, 16. And 6 is 22 divided by 10 equals 2.2. That would be my, what we call it, 2.2 what? Hours. 2.2 hours would be the mean of the absolute deviation. So how much, right? You take your mean and then subtracting tells you how much it deviates from the mean. 2 deviates 3.6 from the mean. So how far off from the average is it? And then you take that deviation, you add them up and you find the average. So this is the average deviation. This is the average distance that each number is from the mean. All right. And that tells us important information. Is our data, is it tight? Is the data sort of close to each other, or is it spread out? So that's the usage there. Which measure of variation can you use to distinguish between dataset A and dataset B? What can you conclude about the datasets from this measure? Okay, so the variation, we'll do the mean variation again. Hiya. So let's add them up. So the mean of dataset A is going to be 3, that's 5, 9, 16, 24. No. Yeah, 24. That's going to be 33. And then 42, so 42 divided by 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We like when it's 10. So the mean is 4.2. So the average, so the deviation is going to be 4.2, 4.2, 3.2, 2.2, 2.2, 0.2. And then it's going to be, that's going to be 2.8. That's going to be 3.8 and 4.8 and 4.8. We'll add all those up and find the average. So 2, 4, 6, 8, 10, 12. Oh, well, actually 1, 2, 3, 4. 1, 2, 3, 4 is 40, 44. That's going to be, well, we have 1, 2, 3, 4, 5. That's 20, 25, 25, 30, 32. 1, 2, 3, 4, 5. That's 20. That's 25, that's 30, 32. 32.4 divided by 10 gives us 3.24 for our deviation of the first data set. Now the mean of our other data set is going to be, that's 5, 6, 7, 8, 9, 13, 18, 18, 24, 24, 33, and that's going to be 42 again, 10, so 4.2. Now the deviation is 3.2, 2.2, 2.2, 2.2, 1, 2, 3, 4, 2.2. That's going to be 0.2. That's going to be 0.8. That's going to be 1.8. 2, 3, 4.8. And 4.8. So we got 1, 2, 3, 4. 1, 2, 3, 4. That's 40, 44 again. And then we have 4, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 20, 24. So a little bit smaller of a deviation. This is a much tighter set of numbers. So that's 2.44. So the question says, which measure of variation can you use to distinguish between data set? We would use the deviation, average deviation. And what can you conclude about the data sets? Well, I know that data set B is more is tighter. There's less of a variation. A has more variation. This is a bigger variation. This is a smaller variation. So these numbers are tighter around the mean, so they're closer. This is a little bit more broad and spread out. So how can we write that? Data set B has smaller variation. Smaller variation. All right, good. It's important. And 63, the frequency table shows the scores and students on a test display the data in a histogram. All right, so histogram, again, has axes, and we're going to put the points on the x-axis, and we're going to put the frequency. Let me see if I can write that. Frequency. So we're going to do this first set is going to be, let's make a little bit smaller. So this is 76 to 80. This is going to be 81 to 85. This is going to be 86 to 90. And then 91 to 95. And then this will be 96 to 100. We'll go back to my big one. Don't need that little thing there. Okay, and frequency, we got 8, so I don't know, we can go by ones. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We'll number it 2, 4, 6, 8, 10. So 0.78 is a frequency of 4, so we'll go like this. Boop. And 81 to 85 is 2, so that's going to look like that. 86 to 90 is 7. Okay, 7 is there. So 7. 91 is 5. That looks like it's about there. And 96 is 8. So it goes above that one. And then you can color it in a certain color. You can just, you color that somehow, sometimes. A lot of people will gray it out. And sometimes you have little dash marks, like very faint dash marks, just to show that height. I'll show you what I mean by that. So you can do something like this and this, and you can go, oh, no arrows, sorry. And you can go, no arrows. So you have sort of like, so it's, that's going to be 5. That goes to 7. This goes all the way to 8. 6 goes to there. Boom. Something of that nature. So sort of your numbers and where that goes to. All right. So that is a frequency table, and you tend to have a title also at the top. Shows the scores of students on a test. So we would label it something like student test scores. Good. So that would be a nice histogram. The histogram shows the ages of people watching 2 movies in a theater. Describe the shape of each distribution. Okay, what would the shape be? Let's see. It skews. I think we use that term, skews to the left. So movie A skews to the left, and movie B would skew to the right. So we have less numbers on the left for A. Movie B skews to the right. Which movie has older viewers? So A, movie A skews left. Movie B skews right. And B, which movie has older viewers? Well, that's going to be older viewers is going to be frequency. It's going to be movie A. Movie A has older viewers because there's more. There's 40 that are above 50, and there's only 16 that are above. And this is much younger. There's more younger people. Which movie has older viewers is going to be movie A. Okay, good. That's good. I think that's pretty clear. The frequency table shows the gas mileages in miles per gallon of several vehicles. What is the most appropriate measure to describe the center to describe the variation? So to describe the center, I mean, I guess I would do the median. The median would be a good center, would describe the center. Median means middle. Middle means center. That's good. And then to describe the variation would be, well, I mean, look, we've used the median variation. You can also, I mean, the interquartile range, interquartile range would be one of them. Another one would be the median variation. Yeah, would describe the variation. Yeah, I mean, both are good. Oh, and that's it. Okay. Yeah, lots of stats, a lot of statistical information there. Probably not well versed at it. And if you're not, do what I did. I forgot about the average absolute deviation. So it's not a bad thing to go back and review. That's why we're doing this. We're finding those gaps. We're finding those things that we forgot about. And it's natural. Can't memorize everything. But when you review it, you should be able to remember how to do it relatively quickly. Okay? Have a great one.